Hello students, today we are doing lesson 2.6 on square roots and radicals. So just to review what we had done earlier in the year was we had talked about exponents. So when we had 4 squared, that meant 4 times 4, which equals 16. Okay, so today when we work with square roots, it's going to kind of like be the opposite of this. So we're going to start with the 16 and we're going to get to the number 4. So when we talk about these numbers, we're talking about squares. And everyone got multiplication charts in my class. And if you look at your multiplication chart, you have a whole diagonal line of yellow highlighted numbers. And those numbers are 1, 2, oops, not 2, sorry. Let me fix that. 1, 4, 9, 16, 25, 36, 49, 64, 81, and 100. There's 2 more, I think, on your multiplication chart, but we'll just start with these. So each of these are called perfect squares. And what that means is that you have 2 factors, like 1 times 1 equals 1. 2 times 2 equals 4, right? 3 times 3 equals 9. So it's the same factor both times. 4 times 4 equals 16, and so on. 5 times 5, 6 times 6. So those are called perfect squares. Well, when you take any of these and you put them under a square root sign, then you're going to be able to find what the square root of it is. So it's a little bit like division, kind of like backwards working from what you've already learned, but it is not division. Okay, so a square root sign also looks like a division sign. So if I had a square root, this is the square root sign, of 16, which is what I just did up here, my answer would be 4, okay? And that's because the square root of 4 times 4, which is 16, right, equals, you just bring out one of the 4s. So 4 is my answer, okay? Now, let me do this whole section, this whole lesson is just a bunch of examples to kind of get you used to how to do these problems. Okay, so example 1 is the square root of 25. So they want you to find the square root of 25. So look up here in my examples up here. When we see 25, we say what times what, which is 5 times 5 equals 25. That are both the exact same. So since I have 2 of those, the square root is just 5. And that's my answer. Okay, example 2. Okay, our first 3 examples are super easy, just like this. Then we're going to get into some harder ones. So example 2 is the square root of 36. So what times what, same number, equals 36. And that's 6 times 6, right? Okay, example 3, you could try to do this one on your own. I'm not going to pause because it shouldn't take you hardly any time. What's the square root of 4? Okay, you should say what times what equals 4? 2 times 2. So the answer is 2. Okay, so that's the super simple ones. Now let's go on to a different type of problem you might see. Example 4. This one is actually pretty similar to everything. If I have the negative square root of 16, then when you have a negative out front, you just do the same. You just keep that negative out front, and then you say the square root of 16 is 4. So my answer is negative 4. Okay, pretty simple so far. Okay, most kids don't have a problem with all this. But now we're going to talk about a different type. It's not a square root, it's a different type of radical. So you notice in your title, it's called square roots and radicals. Well, square roots are numbers that can be squared, right? These perfect squares. Well, now we're going to have other things. Like we will have a cubed root. Okay, and this is how you say this, cube root. Okay, you might have a 4th root. And there's even 5th roots and 6th roots. Okay, but these 2 are the ones that we will be working more with. A square root is actually, you could have a little 2 right here, but it's just implied that there's a 2 there. But square roots mean that you're working with squares that are have the 2 in them. Okay, so if we look at example 5, we're going to talk about a cube root on this one. We have the cube root of 27. So that means that little 3 right there means that I need to find something that times itself 3 different times. So on this one, I know that 27 is 3 times 3 times 3. Okay, so this is 9 times 3 is 27, right? Okay, so that means that if I have 3 of those here, then that means I just take out one of them as my answer. So my answer is 3. Okay, does that make sense? Let's do another one to kind of help you understand that. So example 6. Oh, okay, this one's a little bit, one more thing that's different. They never want to do too many that are the same here. We have the cube root of -8. Okay, so now we have a negative on the inside. Okay, we don't work with negatives on the inside normally like in a regular square root because it has to have 2 numbers that are the same. And if they're the same, like if you have -2 times -2, that's a +4. So we don't usually work with negatives with square roots. But in this one we do. The cube root of -8, that one would be the cube root of -2 times -2 times -2. So make sure that this is right. -2 times -2 is +4 times another -2, that's -8. So see, I got the same answer. So -2 times -2 times -2 is -8. So that means when I'm finding my answer, I have 3 -2s. So that means I can take out just one of them. So I'm looking for 3 because of that little -3. I mean, not negative, that little 3 in front. Okay, example 7. Okay, on example 7, we have the 4th root of 625. So when we're in class, I always tell kids to guess what the number is going to be. And so I want you to kind of try to guess on your own. You don't have to write it down, but try to think. I want 4 numbers that when multiplied together, the same 4 numbers are going to equal 625. So I usually have kids saying, oh, I don't even know where to start. But there's an easy way to know where to start, and that's by your last number here. So if that last number is even, then you're going to have an even number. It might be 2, 4, 6, 8. But if the number ends in 5, sometimes it might be 5. So we're going to try 5. So I'm going to see if 5 times 5 times 5 times 5 is going to equal 625. Now remember, I'm looking for 4 of them this time because this is a 4th root. So I'm going to check this. 5 times 5 is 25. And again, 5 times 5 is 25. And I already know because 25 times 25 is a number that comes up a lot when you're doing math a lot. And I already know that that is 625. So that means I have 4 5s as 625. So when I'm trying to find the 4th root of 625, the 4th root of it is okay, sorry, I got interrupted by the phone. I'm not sure where this stopped, but here is the answer to number example 7. This is the 4th root of 625. That's 4 5s written down, so I take out one of them because this is a 4th root. Okay, example 8. Example 8 is find the 5th root of 1024. I will probably not be putting any 5th roots on any test, but we're going to talk about this one anyway. So I said earlier when you end with a 4, it's probably going to be an even number, so you could always start with that. Like, let's say, remember, we need 5 this time. So if I do 2 times 2 times 2 times 2, that's going to come out to 4 and another 4 and a 2. So that's 16 times 2 is 32. That's way too small, right? So it's not 2. So maybe we could try 4. This is just the way that you work when you're going through these problems. Okay, 4 times 4 is 16. Another 4 times 4 is 16. and another 4. Then I could work my 16 times 16 over here. Okay, I know that that's 256 times 4. Okay, so is that going to make 1024? Yes, it is. Okay, because if you could think of it as like 250 times 4 is about 1,000. So the fifth root of 4 times 4 times 4 times 4 times 4, this is, all of this equals that 1,024. So the fifth root of that is 4 because I have 5 4s. Okay? Okay, so example 9. Now we're going to get into some fractions. Okay? On example 9, we have the the negative square root of 4 over 9. So this is the same as saying the square root of 4 over the square root of 9. And notice I put the negative sign up on the top. You do not ever want to leave your negative signs on the bottom. It's very hard to see them. And right straight dab in the middle is okay, but usually if you put one in the middle, it gets lost in that bar. So I don't like them to be in the middle. So I just moved it up there to get it out of the way. Now I just do each of these on their own. So the square root of 4 is 2. And remember I have the negative sign in front, so that's negative 2. And the square root of 9 is 3. So we are back to square roots, not cubed roots or fourth roots. These just need to be 2 times, right? So 2 times 2. This one is 3 times 3. So that's how I got those answers. Okay, there are 15 examples, so we have 6 more to do. Example 10 is another fraction. Okay, this time we have the cube root of negative 27 over 125. So I need to find these individually. So this is like doing the cube root of negative 27 over the cube root of 125. Now, for notes purposes, we're writing all of this. But in the future, you don't have to write this step. You can just do it from that first step over there. Okay, so the cube root of 27. Something that equals 27 when I multiply it 3 different times. Not add it 3 times, but multiply. So if I had 3 times 3 times 3, that'd be 9 times 3 is 27. So see, I had that 3 times. So that's going to be a negative 3 on top. Down here, I'm trying to make 125. So it ends in a 5. I'm going to try 5 and see if that works. So I want 3 of them. So 5 times 5 is 25 times another 5. That is 125. So that means this bottom number is 5. And there's my answer. Okay, example 11 and example 12. Okay, these are a little bit different than what we've been doing. So on this first one, example 11, it says, and write all this down in your notes, write the square root of 25 equals 5 using exponents. So they don't want the square root on there. They want you to rewrite with these numbers, so with 25 and 5, but put an exponent somewhere. So they took away the square root, and now I'm going to put an exponent. So could I put an exponent here and that be true? No. But if I put one here, would that be true? Yes. So this is what they want you to do, is rewrite the problem with exponents. Now on example 12, it's kind of like the opposite of example 11. It says write 4 cubed equals 64 using radicals. So remember, radicals is like the square root sign, the cube root sign. Okay, so I'm going to rewrite these numbers. I'm going to put 4 equals 64. I'm going to take off the exponent. Okay, they don't want exponents. Instead, they want radicals. So on this one, because it's a cubed right here, then that means when I write my radical sign, it's going to be a cube root. And that's how they want that one written. Okay? So I'm just going to do one more kind of off to the side. If I had 5 to the 4th equals 625, okay, and they said write this with radicals, I'm going to leave off the exponent and I'm going to change this to a radical. But it's not square root. It's not, I have to put this 4 on the radical sign. Okay? Okay, next one. Example 13. Okay, example 13 is, now we're going to do some more math in here. We're going to do 8 times the square root of 5 plus 4. Okay, anytime you have a number right next to something and you don't know what to do, that means times. Okay, so I'm going to first add what's inside the radical sign in this square root sign, because it's kind of like a parentheses. You do what's inside it first. So 5 plus 4 is 9. Now I'm going to see if I can do this. Does the square root of 9, do we know what the square root of 9 is? Yes, the square root of 9 is 3. So now I have 8 times 3, which is 24. Okay, example 14. Okay, example 14 and 15 are not radicals. I think they just threw these in here to kind of say, hey, you need to know how to do these kind of problems. So we have 7 plus 11 divided by 3. Okay, on order of operations, division comes before addition. But on this one, when you have everything on top of a division bar, or even if it was on the bottom, you need to do those parts first. It's almost like they're in a parentheses. So I'm going to do 7 plus 11 first, and I get 18 divided by 3. And then I do that part. 18 divided by 3 is 6. And that's my answer. Some kids were leaving this like this on a previous worksheet and stuff. And you need to actually finish simplifying it. Okay, and then example 15 is kind of a throwback to something we did earlier in the year. We have 2 times the absolute value of 5 minus 14. So when you have absolute value, we did that earlier in the year, you need to do this part first. It's kind of like it's inside a parentheses. So I have 2 times, and I need to do 5 minus 14, which is negative 9. So 2 times negative 9 is negative 18, and that's my answer. Okay, that's it for today. So you need to go do your homework, make sure that you check with the odds in the back, and that's it for today. Thanks.